Okay, so sum and product of the roots. What we have here is the general form of a quadratic. We're quite familiar with this now. Ax squared plus bx plus c. And we're saying if this quadratic has roots p and q. Now roots are the values of x that you would put into the equation to make it equal to 0. All right, I've said that before. Roots, x-intercepts, solutions, zeros. We use those words to mean the same thing. But if you take this number p and put it in, it makes y equals 0. It evaluates to 0. That's what a root is. And that's what we're doing with factorization, right? We're finding when does the quadratic equal 0? What are the values of x that make it equal 0? What's p and q? What are those roots? All right. If you have the roots and you add them together, it's equal to negative b on top of a. If you have the roots and you multiply them together, the product of the roots, it's equal to c divided by a. Okay? So we're going to find the sum and product of the roots. Firstly, just by referring to b and a, and then we're going to check it by finding the roots and seeing whether they evaluate to the same figure. So we're just going to confirm that it's true. So we've got find the sum and product of the roots. So let's look up here. We've got a is positive 1, b is negative 13, and c is 36. All right. Now, if it has roots p and q, we're told the sum of the roots. Okay, so let's write that out. Sum of roots equals p plus q. We don't know what the roots are yet. We can find them in a moment. But the sum of the roots is equal to minus b divided by a. So that's going to be minus b is negative 13 and a is 1. All right, so hopefully you can see the correlation here. We've got p plus q is minus b, we keep the negative with b, right, divided by a. And so that's going to evaluate to positive 13. The sum of the roots, when you have the roots and you add them together, you get positive 13. Okay, how about for the product of the roots? All right, the product of the roots is p times q, and that's equal to c divided by a. So in our circumstance, 36 divided by 1, the product of the roots is 36. Okay, so we can establish that without knowing what the roots are, just by referring to the general form of the quadratic. So that's part A, done. Part B says, check your answer by finding the roots. Okay, we want to find the roots of this quadratic. We make it equal to 0. All right, we're saying what are the values of x that make the quadratic equal to 0? They're going to be the roots. And so we need to solve this via factorization, right? Solve this via factorization. So this is quite a tricky one because 36 has lots of multiples. So we can go 1 times 36, 2 times 18, 3 times 12, 4 times 9. Look at that, beautiful. 4 and 9. When you add them together, 13, and they both need to be negative. All right, negative 4 times negative 9 is going to give me positive 36, and negative 4 plus negative 9 will give me minus 13. So when we factorize this, it becomes x take 4 times x take 9. Apply the null factor law. So we've got the two roots. Those are the values of x that if you put them into the equation, they make it equal to 0. All right, they're the roots. And so now let's check the statement. What is the sum of the roots? All right, so these are p and q. If I add them together, 4 plus 9 equals 13. What was our claim up here? The sum of the roots is 13. Without even knowing what the roots were, we're able to determine the sum of the roots. here we've established the roots and we can confirm that it's true. The sum of the roots is negative b on a, okay? Similarly, the product of the roots, all right, 4 times 9, 36. The product of the roots, 36, okay? So this question, there's only one question that we require you to do in this exercise, but it gets you to do both ways. Firstly, just identifying the values of a and b and using this part of it. And then secondly, it wants you to find the roots. That means make the quadratic equal to 0, find the values that make it true, and then add them together. Yep, confirm. Multiply them together. Yep, confirm. So I've only got written down question 1 because this exercise is actually quite a challenging exercise. And really, it's not an essential skill for us as we move forward into Year 12 methods and so forth. So leave it with you for some optional extension, like recommend doing it if you're finding what we're doing so far pretty easy. But yeah, it's not a compulsory part of what we need to learn. So let's spend 10 minutes going through the sum